All right, so we're going into our next lesson here in Unit 4, and you're going to see that this is going to follow the same structure as Unit 3 to where we've already developed those angle relationships, and so what we're going to do now is use those relationships to set up equations and solve. And so your next 3 lessons are going to focus on linear systems of equations and quadratic relationships, just like we did in Unit 3. All right, so you can see that our standards here, 10.1 and 10.2, I can use my knowledge of angles formed by parallel lines and transversals to solve problems involving linear relationships. So the focus today, and in this particular lesson for Lesson 5, which begins on page 158 in your workbook, all right, we'll focus on setting up those relationships, and they will result in a linear relationship that you will then solve. All right. Okay, so we're going to skip the opener and kind of treat this as the opener down here. So what I really want you to do is complete this table as the opener. All right, and then pause the video, fill out this table, turn it back on, and we'll see how you do. All right, so let's see what you came up with. So as we work through, I'm going to just make this a little bit taller here so we can maybe see as much as possible with our diagram up here. But hopefully you have 9 and 5 are corresponding. And they would be congruent because 9 and 5 are touching, right, our parallel lines, and so that we know that then we could set those equal to each other. All right, 7 and 10, all right, are same side interior. They would be supplementary because once again, right, the transversal that 7 and 10 are on intersect our parallel lines. So there would be our equation that measure of 7 plus 10 equals 180. All right, 2 and 4, all right. A little review there. Those are vertical angles. We know all vertical angles are congruent, so the measure of angle 2 would equal to the measure of angle 4. Now, notice on 13 and 11 here. So we can identify 13 and 11. They are alternate exterior angles, but notice they are not, all right, on parallel lines, right? So our transversal is E here, and we don't know that N and J up here are parallel. So we can identify them, right, but we can't come up with a particular relationship for those. All right, 8 and 10 are alternate interior angles, and once again, they are on a transversal that intersects our parallel line, so we know that if that happens, alternate interior angles are congruent, all right, and those measures would be equal to each other. 8 and 7 are a linear pair, all right, and we know that all linear pairs are supplementary, all right, and so we know that those two measures would equal to 180 degrees. And then 9 and 3, right, there's no relationship. There's no transversal that intersects 9 and 3, all right? So we know that there's no relationship there, so we don't have to worry about anything else for those. Now, the idea here is that you're going to use these types of ideas to set up your equations and solve, all right? So we want to identify the types of angles. We want to identify the relationship, and then that allows us to write our equation and solve. So now, let's go ahead and flip to page 159 here. And let's look at problem 1 here. All right. So now, once again, all right, we want to identify the types of angles. We want to then identify the relationship from those angles and then write our equation and solve. So notice when I look at equation or problem 1 here, all right, we have parallel lines, so that's good. All right, and we have corresponding angles, all right, on those parallel lines. And we know from what we just did that corresponding angles will be congruent. All right, so what we know is that the measure of angle 1 is equal to the measure of angle 2. All right, so then if we take 3s minus 10 and set that equal to 110, all right, there's our equation. All right, and now we can go through and solve, all right, and we can get to a value of 40 degrees, all right, for s. And then once again, if we go back and check, all right, we can go back and plug 40 in, and it should give me 110, right, if these two angles are in fact equal. So 3 times 40 minus 10 would be 120 minus 10, which does give me 110 degrees, right? So we know that the measure of angle 1 is in fact 110 degrees, all right? And so we found our value, we checked it, we know it's all good. All right, so let's do one more together here. Let's look at problem 2. All right, and when we look at problem 2, once again, all right, we have these two angles here. All right, they're on transversal N. All right, and they are same side interior angles. And now, what's the relationship? All right, they're same side interior angles, all right, on parallel lines. So what that tells me is that we know that same side interior angles are supplementary. All right, and then once again, now I can just put those equations into that relationship, and you can see that we now get to a linear equation. So we can combine like terms here. So 17u. All right, so my video cut off on me, and I didn't realize it, so I finished the problem. I believe I was right about here, so I'm just going to continue with the problem here, just so you can see the work. All right, so once again, I think you saw that I set up the equation. It was supplementary. And if we go through and solve this equation, we get to u equals 9. All right, and then what we want to do is go back and, all right, plug u in to make sure that it makes our equation true. It also gives us two angles that are positive and between 0 and 180 degrees. All right, and so you can see that as I go through here, I do get 180 equals 180. And then you can see here that this angle is 111, this angle is 69. All right, so they're both positive, they're both between 0 and 80, so our work is done. All right, so you get to finish the rest of the lesson, and I will see you next time.